In this video, we're going to take a look at the different classes, different types of machine learning problems, ML for machine learning problems. So there are certain sort of canonical categories or classes that people lump different machine learning types of problems into, and we'll try to more or less define what these different types are. And so I should say these are not necessarily well-defined classes in the sense that they're not necessarily mutually exclusive. You'll see what I mean. So the first dichotomy that is often distinguished is supervised versus unsupervised. Supervised learning versus unsupervised learning. And supervised is probably the most canonical type of machine learning problem. So what is supervised learning is a problem. We're given a sequence. Usually people write it this way, x1, y1 up to xn, yn. So this is given data, we usually say. And here, so we usually call the xi's the data points, and we might call the yi's, so for classification, it'd be like the class or the value or the target value. So given this data, so the task is to find a function or choose a function f. So some function, I won't define it formally, so that takes a value, a data point x, maybe a new data point, and gives you a y for that. So of course, if you were given one of these original data points, then you could just, if I gave you x1, then I would probably want to define f of x1 to be y1. But the problem is that you have to generalize. So you're given now a new x, an x which was not from your original data, and you have to figure out what y you should associate with that x. So now you may be saying to yourself, how in the world could I possibly do this? And you would be justified in asking that question, because in general, this is not a well-defined mathematical problem. This is an ill-posed problem. There's no way that you could expect to find if there, in some sense, if there is a correct function. There's no sense in which there is a correct function for this very sort of ill-posed type of setup. But oftentimes, real-world problems, you get this data like this, and you have to do this. So by making certain assumptions, you can try to do the best you can. So we can break supervised problems up into classification and regression. Regression, kind of a funny name for what it is. So classification is when, so we could characterize classification when the yi's are from some finite set. That's basically what people mean by classification. So it's this problem when the y's are from some finite set, and regression is when the y's are from, usually for regression, almost always, the y's are in R, there's some real values, or less commonly, but sometimes they're in d-dimensional real space. That's usually what people mean by regression. And this is just it's called regression for historical reasons that I won't go into, but not really for any good reasons. But that's what we call it. That's just just terminology. So regression, so let me give you an example here. So classification, an example. Suppose I had points in 2 dimensions, so the let's see, how do I want to say this? So my x's, maybe I should change notation to be clear here. So let's make these superscripts. Because I'm going to want to have these x's be multi-dimensional. So I could maybe put parentheses around this to emphasize these are not exponents. This is just denoting, that should be 1, n, 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 x, I, y, I. So now, let's say that x1 is the, so let's say that these x's, like the xi data point, is a point in two-dimensional real space, and I'll write that point as xi1, xi2. Sometimes people do this, put little parentheses so that you know it's not an exponent. But I'll drop those. You know what I mean. So the first coordinate, let's call x1, and let's call the second coordinate x2. First coordinate, second coordinate. And say we get some data points here. So let's say, and I'll write the y. So if that's x1 has this x1 x11 is that, and x12 is that, then I'll write 0 if y1 is 0. So that would be 0, and I'll put a 1. So maybe x2 is this point, and y2 is 1. So I get all these zeros, and I get some 1s, all these different points. So where I'm drawing the 1 is the x part, is the data point, and the fact that I drew a 1 versus a 0 is meaning that it was the class y associated with that was 1. And now you get, say, this data, and you have to figure out, how am I going to classify a new point? So now, here's a new point here, where the question mark is, are you going to classify that as a 0 or as a 1? Well, you might say, well, it's closer to the zeros. All kinds of things you might do. Maybe you draw a line and say, well, it falls on the 0 side of the line. But then if there was a 1 over here, what would you do? So that's a classification problem. A regression problem, little example, it's going to be a different, maybe I'll just draw it this way. So now let's suppose, for our regression example, that the xi's are just real valued, and the yi's are also real valued. And now this will be my x value, and this will be my y value for each data point. So now we'll get a bunch of data points. And so maybe the first one is here, the first pair, x1, y1. Second one's here. So I get all these different data points, something like this maybe. So I get all these points. And now maybe another weird one over there. And now your task is, I give you this point, or no, not that point. I give you this x, and it doesn't have a y associated with it. And your task is to figure out what y should I associate it with that value. Or more generally, for any given x, what y should you associate with that x? So you need to come up with this function. So you need to figure out some function. So maybe you'll choose a function like this, because you want to account for this one or something, or maybe you choose a line. You have to choose a function. And so if I gave you that x, then you would say that's the y associated with it. So that's the distinction between classification and regression for supervised problems. And since it looks like I'm running out of time here, let me stop there, and then we'll do unsupervised in the next video.